So, put this away here. So as I was saying, the grading in my math lab has been adjusted now so that you should be able to see the actual number of homework points you've earned in the course, all right, in summary. So guys, do you have any questions about anything in particular? Just to remind you, next class is the final exam part 1, right? I allow you 3 pages of notes, front and back. Final exam part 1 will cover tests 1, 2, and 3, as well as quizzes 1, 2, and 3. I do think that like the exercise sheets I've given you guys are helpful, probably somewhat representative. But honestly, like those exercise sheets, aren't they pretty much just a compendium of everything that was in my math lab homework anyway?
You said tests 1, 2, and 3?
Yeah, as well as quizzes.
So what's part 2? Is there going to be a part 2?
Yes, part 2 is focused primarily on chapter 7, and that's after Thanksgiving break. I have to give that on the final exam day. I have to stay in communication with you guys until the end of the course, which is technically after Thanksgiving, the final exam week. As much as I'd love to just finish things up, it is not allowed for various accreditation reasons and so forth. But just to be clear, like final exam part 1 is the one that if you do well on, I will take that grade and replace your test 1, 2, or test 1, 2, and 3. I mean, if you do better on final exam part 1 than you have done on any of the previous tests, I will replace all of the test grades. Yeah.
I'll take it.
Yeah.
So I'm at 90 on this part 1. All the tests I took up to this point will be 90s?
That's right. Unless you made like a 95, I'm not a monster. I'm not going to take away that 95. Of course, 95 out of 150 ain't great.
No, I'm saying I'm not at 7. So what I'm saying is that I'm at 90, I'll not see up to 8.
Yeah, could happen.
Like that.
But that is, usually speaking, I mean, that would be a statistical anomaly, Like, it is not likely for these things to happen.
I mean,
You know.
my test grades in here, it's kind of likely if I do good on my final.
Yeah, 'cause it's just been, the numbers been going up.
You're going up?
Yeah.
See, right, and so that's the sort of thing. So I think sometimes there's a couple different things that go on in a course, right? Like one is you get used to my style, right? I maybe teach different than anybody else you've ever had before. Totally possible. So you get used to what the expectations are of your teacher. That's one thing, You maybe start to notice things like I give a quiz and the test is like the quiz. So if you study the quiz, it can help you, right? You make use of the page of notes. Like a lot of you in test 1, you're like, what, we get a page of notes? It's like, yes, you get a page of notes. But you guys came, and then there was another day, I think we had a quiz and people were like, what, there's a quiz? So there's been some events in here that could have gone better, right? So I think there is very good reason to expect that a lot of people can do better on the final exam than they have on previous stuff. And just generally speaking, I like to believe that when people study, they do better. That's usually true most of the time for most people and most things. There are exceptions to that rule. I've experienced it. I once had a exam in graduate school called a qualifying exam in physics, and I did best the first time I took it. And the farther I got into the graduate school, the worse I did on the thing. So, but it turned out to be okay. I passed it at the master's level. That's all I needed. Anyway, so let's see here. So yes, final exam part 2 is not in class, right? We don't come back after Thanksgiving, generally speaking. At least we don't meet as a class. There will be professors here, I guess, at some time, and probably be some students wandering around too. I know that some of you guys will still stay in the dorms after that, right? But you have to make special arrangements and such, I think, right? Yeah. You probably know more about that than I do, so I won't try to inform you anymore. I would point out, and okay, so let's talk about test one, right? So, what's the right way to study for a final exam in math? Like, first of all, I mean, it depends on the course, right? But in here, something to keep in mind is you get 3 pages of notes, right? So as you're working, as you're reviewing these tests, you need to be thinking to yourself, do I have the essential truth that I need from this problem on my sheet of notes, right? Like, maybe I should write a sentence, if a problem's like this, I should do this, like just like a little internal dialogue on how you solve the problem, something like that might be useful to you, I don't know. Maybe just the process of writing that down on a piece of paper will help you solve the problem. Possible. The other thing is, should you just like print out the solutions or open up the solutions and just look at them? No, this is absolutely the wrong way to study, right? What you should be doing is going to this blank one, open this up, work the problem cold. See if you can do it. Let's try that. Everybody try that. See if you can solve minus 5/3 x plus 4 equal to 7/3. You got some paper handy? I'll give you 30 seconds. I try to hum some Jeopardy music, but it seems like it's too soon. Actually, maybe it's not too soon. I think Alex Trebek has been kind of in poor health for a while now. What do you guys think? Is Jeopardy going to live on, or is it going to die?
It'll probably die.
Probably die.
Because, I mean, he ran the show.
He was the show.
Yeah.
That's probably fair. I wish SNL would start doing Celebrity Jeopardy again. You bring back Will Ferrell, do some Celebrity Jeopardy. It's one of my favorites, especially the ones with Sean Connery. Anyway. Oh, careful of that chair. Man, I can't even see it from here. What's the point? And the thing, well, if I turn the lights, it turns off all the lights, right? So
There's not like a half light?
there is no half light, no. What's that? Use the blind? Okay, yeah. Sure, let's go for it. Don't have to open all, just do one of them.
And then he opened one of the
Well, can you guys still see anyway? I mean, is that good? It probably still won't show up in the camera, but for the folks at home, you know what we're looking at. We're looking at test one, so hopefully you can look at that some way or another. All right, so I'll review the steps here. We got minus 5/3, is it? X plus 4 equal to 7/3. So how should we solve this? Yeah, subtract 4. Minus 5/3 x equals to 7/3 minus 4. 4 is equal to how many thirds? Is 12/3, right? So we have minus 5/3 x equals 7/3 minus 12/3. 7/3 minus 12/3 is minus 5/3, right? Oh. So what do we get? We get 1, right? So the way I did it in the solution was I multiplied by 3 to get rid of the fractions, right? Then I subtract 12 from both sides. But yeah, we get x equals 1. My larger point here is this is a good way to review the tests, right? Work it, independent of looking at the solution, then look at the solution and see, did I do something wrong? And if so, what did I do, you know? So problem 2, we have 7x plus 18 equals to 3x minus 26. If you had to give me in words like the big idea, what is the big idea of solving this?
Get the same variable together.
Yeah, put all the x's together, right? Isolate x and get the numbers to the other side. And of course, if we look back at the solution, that's what I did, right? I moved the x's to one side, I moved the numbers together. That gave me 4x equals to minus 44. And so that gave me to x equal to minus 11. So you guys just jump in if you got questions about anything, if you'd like me to skip ahead, and there's a particular one you'd like me to spend more time on, just let me know. Trying to keep looking at the blank one here. Solve 4 times x minus 6 equals to 8x. Like, see, when I see something like this, I think, oh, I should divide by 4. Because, 8 goes into 4, it's just 2, right? So if I divide by 4 as my starting move, the problem becomes much easier. See? So I divide it by 4, I get x minus 6 equals to 2x. And then we isolate x, right? And that gives us x equal to minus 6. So all these linear problems are the same. We basically want to perform allowed algebraic steps, either adding things or subtracting things from both sides, or dividing by a non-zero number to isolate the variable, right? Or more generally, to isolate an expression involving the variable, and then hopefully we can just solve for the variable alone, and that's it. Ooh, problem 4 is more troublesome, isn't it? Absolute value of 7 minus 3x equals to 10. What should we do here? There should be 2 solutions, right? That's the kind of thing that definitely should be on that formula sheet, right? And maybe an example. Maybe this would be a good example to copy onto the formula sheet, right? How's it go? Either you have 7 minus 3x equal to minus 10, or you have 7 minus 3x equal to 10. And so we solve those just like we solve problems 1, 2, and 3. And in so doing, I end up with 17 thirds and minus 1. Problem 5. Given lines x plus y equal to 10 and y equal to 3 minus x, are these lines parallel? Are they perpendicular? What is it? How do we care? What does it mean for 2 lines to be parallel? It means that they have the same slope. All right? Or they could both be vertical lines, right? Slope of a vertical line is not defined, but if I look at like x equals to 2 and x equals to 3, these are vertical lines, they're parallel, but they have undefined slope. So how do I figure out what the slope of these lines is? Well, the second one's easy, right? Excuse me. 3 minus x has slope what? What's the slope of the line y equals 3 minus x? Can somebody tell me?
3.
Nope. 3 would be the y-intercept. What? Negative 1, right? Because minus x. What about the other one? X plus y equal to 10. Well, if I subtract x from both sides, right, I'll get y equals to 10 minus x. So what's this? In fact, the slope of both of these lines is minus 1. And so what that shows me is that, in fact, they're parallel. Here's a picture of it. What would it take for them to be perpendicular? Like if I gave you y equals to 2x, and then I said, what lines are perpendicular to y equals to 2x? What would their equations look like? Can you tell me?
Which one would you like plus x?
No. So So y equals to 2x. And perpendicular lines of form what? Y equals to blank times x plus any constant. What fill in the blank for me? Yeah, it's a number. Mhm. So 2x looks like this, roughly speaking. So you can visualize the perpendicular lines, right? That's not like a big deal. You can kind of see them, right? They make right angles. Anything like this would be a perpendicular line, right? Like different choices of b will give you different y-intercepts, but they should all have the same kind of slope. What is that slope? It's negative, right? And it's not as steep though. It's much more shallow. So there's a 2 involved. The answer is minus a half. So the perpendicular line, if you give me a line and I suppose I give you a line and then I ask you, okay, so find me a perpendicular line to that line. You want to find a new line which has negative the reciprocal slope of the given line. So you minus 1 over the slope to get the perpendicular line. Are all lines either parallel or perpendicular? Well, the answer is no. I mean, there's all kinds of other things that can happen. They can just be kind of skew, which means they're not quite perpendicular, they're not parallel, they're just in between. So, ooh, a word problem. Woohoo! So what should we do when faced with a word problem? I'd say first things first, draw a picture, label the variables, decide what you know, what you don't know. What are you looking for, right? These are questions you need to ask and answer. In this one, I tell you the field's a rectangle. And we're looking at length and width, right? So we want to find the length and the width and also the area. And we're given that the perimeter of the playing field is 1,000 feet. So I make a picture. I label one side the width and the other side the length. Remember the width, the length rather, is 100 feet longer than the width. So that means L is equal to W plus 100. Sometimes the word problem might be like the length is twice the width, right? If the length was twice the width, instead of putting W plus 100, you'd put 2W, right? So you have to think through like what's the right formula for L if you have a relation with the width. And then what's perimeter? Perimeter is the sum of the lengths of the sides, which in this case works out to W plus W plus W plus 100 plus W plus 100, all equal to 1,000, which gives me 4W plus 200 equal to 1,000. And then I solve for W, and I get 200. And then to find the length, I go back, I add 100 to get the length is 300. And then area is length times width. So that ends up being 60,000 square feet. So I will tell you this, if I do put a word problem on the final exam part 1, it'll be very, very similar to one of the word problems I've already asked, okay? So. Ooh. Let's see here, problem 7. Solve this inequality and give the answer in interval notation. How do we do this one? I think it's kind of the same story that Harold was telling me a few minutes ago, which is isolate x, right? But got to be careful. We can't just divide by a negative number now, right? If we divide by a negative number, it flips the inequality over, right? We can add things, we can subtract things, we can divide by a positive number. Those will maintain the form of the inequality, but watch out for dividing by a minus. So let's see what I did. Well, I just added 2x to both sides to get rid of the minus problem. And then I subtracted 5 to the other side, so I get 3 minus 5 is greater than 2x. which gives me minus 2 is greater than 2x, then I can divide by 2. That doesn't change things because 2 is positive. That gives me minus 1 is greater than x, which is equivalent, also known as x less than minus 1. And I asked for the answer in interval notation, which means you got to write it in like this kind of notation here. In this case, it's minus infinity to minus 1. If you're unsure about interval notation, it would be a good idea to like make a list of like 10 examples of inequalities that I've then translated to intervals. So if you're unsure, you can like check your list of examples and say, oh, okay, he did say if x is less than minus 1, in interval notation, that looks like minus infinity all the way to minus 1, right? And so forth. Like if you had a list of 10 diverse examples, then if you've got some hole in your thinking about interval notation, that could maybe fill it. Now, absolute value greater than is a little bit tricky, right? Because absolute value greater than breaks into two cases. Either we're going to have 2x plus 8 less than minus 4, or we're going to have 2x plus 8 greater than or equal to 4. So we have to solve both of those separately. And when I do, I either get x is less than minus 6 or x is greater than minus 2. So those are the two different separate disconnected cases which solve this inequality. And so we need this U for union of the intervals here. Any questions about this? Yep.
How many questions do you think will be on the test round?
Probably enough. Enough to keep you busy for 75 minutes. Yeah. Like it'll be longer than a test for sure. But it will be, we'll do it in one class sitting, so it can't be super, super long either. If I had to guess, I'd say 8 pages. Probably. No, I don't want to grade front and back. You can, no. No. Let's see here. Now, notice the difference between problem 8 and problem 9. They're very similar, right? One is 2x plus 8 greater than or equal to 4. Come on, go away, bar. Stupid bar. Notice the difference. 2x plus 8 greater than or equal to 4 absolute value, or the absolute value of 2x plus 8 less than 4. These are complementary problems, right? If your x solves the first one, it won't solve the second one. If x solves the second one, it won't solve the first. If you think about these logically, right? But anyway, more to the point here. We don't have greater than or equal to, we have less than here, which means that we can solve it like this in terms of what's called a compound inequality. Minus 4 less than 2x plus 8 less than 4. All right. So the same x is satisfying both of these conditions. That's why I can do them both at once. In the previous case, different x satisfy the conditions. That's why you have to do them separately. But anyway, I subtract 8, and then I divide by 2, and lo and behold, I get minus 6 to minus 2. If you look at this, the boxed answer for problem 9 and the boxed answer for problem 8, if you took the union of both of those, put them together, you'd get everything. See, what's missing here is just these points. So if I did give a pair of problems that were like this, you could check your work on both of the problems by checking if both of the problems put together give you everything. And, I'm not saying I will do that. I'm saying if I did, there's a way to check your answer. Oh, so much suffering on this problem. Oh, man. So here, I give you the graph of a function, right? And what was actually given in the problem statement was what? Just this, right? So I'm trying to add solid dots to the endpoints here to be clear. I hadn't done that at this stage. I know, but if I do this on the final, I will add like a solid dot to indicate that it ends there and doesn't continue. If I want it to continue on, I'll put an arrow on it. All right? Anyway, so what's the domain? So the domain, we're looking for all x that are in the graph. And so we got like -8 not included, all the way over to 2. 2 is included down here, but excluded up there, that's fine. And then -2 all the way over to 2, not included. There is no x in the graph from 2 to 4, so we'll have to omit 2 to 4 in the domain. And then it starts again at 4, not included, and goes all the way over here to 8. So we're looking at -8 all the way over to 2, both -8 and -8 and 2 not included, and then 4 all the way over to 8 for the domain. That's what I have written here, -8 to 2, and then 4 to 8. 8 is included because there's no circle there. The range, if you look at y going from -6 all the way up to 8, all those values are attained somewhere in the graph. Wherever there's a jump in terms of y here, those values are attained over here on this other part of the graph. So there's no jumps in the range. F of 0 is -2. I look at x equal to 0, I follow the graph down, see where I go to -2, so f of 0 is -2. F of 3, that's in no man's land, there's no graph there. So f of 3 does not exist. 3 is not in the domain of the function. Any questions? All right. Here I gave you 2 points. Remind you what the problem looks like. I gave you 2 points. I said plot these points, -6, 4, and 6, -2, and find the equation of the line that passes through the given points and graph that line. So I think I had people do one part of this question and not the other 2 parts, or some other people did 2 parts of the question, but not the 3rd part. Like, people found a diverse and varied way of getting this problem wrong. So there's no need to miss any part of this problem. You can do all of them. Here they are. So plot the point, connect the dots is how we graph the line, right? Take you back to your youth. I mean, you guys are still young. What am I talking about? M is the slope, so delta y, changing y, we're changing x. I get -1/2 here. And of course, the 0.6 -2 is on the line that's given, so I can use point slope, -6 -1/2 times x -6. There you go. There's a formula for the line. Of course, you can simplify that and also write it as 1 -1/2 x. Anyway, definitely be ready for a problem involving finding the equation of a line, graphing a line, graphing points. These are very, very standard questions for the final in this course, all right? Problem 12, I gave you a circle, basically, and or maybe it might be an oval. It's probably an oval. And I said, oh no, well, I don't know what this thing is. Anyway, it's a picture. And I said, find all the points with x squared equal to 4. This is kind of an adventurous, outside the bounds. This was not in your homework. This is a bonus question, right? And so basically the logic here is if x squared is 4, that means x is plus or minus 2. So I just have to look at 2 and -2 and see where the graph goes. It goes at these 4 points. So those are the 4 solutions, approximately 6.2 and -4.3 were the answers.
There's a question like that on the test, would it be bonus too?
I mean, there might be a bonus. I mean, there's likely to be a bonus question, actually, on the final. Sure. Hey, that's a good question. How much is the final worth? Final exam part 1? Mm-hmm.
200?
I think think that's what it is, 200 points. Yeah, part 1 is 200 points, and then part 2, which is again after Thanksgiving, is 75 points. Now, only part 1, I only use part 1 to figure, replacing the test 1, 2, or 3 grades. All right, part 2 is a separate issue. It's just 75 points. You do it or you don't. All right, I mean, do it. Please don't not do it. Like, don't just skip that and turn a C into a D. That would be so tragic. Don't do that. It should be relatively easy to do. I mean, I don't foresee final exam part 2 being like a super big deal. It should take you probably a couple hours. You'll be done with it. All right,
A couple what?
a couple hours. I'm assuming you work slow and careful. Yeah, so a couple hours. I mean, if you really, really understand everything already, it might take you 30 minutes. I don't know, whatever. I'm not really trying to say it must take hours on end. That's not at all my point. But it will be about the Chapter 7 stuff, okay? So, which, so I think, I mean, I got to double check on this and take a good look at Chapter 7 homework again, but I'm pretty sure I've covered all of the major ideas, the major ingredients in Chapter 7 in lecture this semester already. So I don't foresee us having a formal lecture after break. I'll probably just be available to meet with you by Zoom if needed or something like that. All right. So, but we should expect to have a formal Zoom meeting during the final exam period. All right. When is that?
One of the days.
One of the days.
I can't keep up with it.
Yeah, me neither.
What, the part 2?
I have it.
The part 2 form?
Yeah, I'll
The
tell.
schedule that there is. There's a whole schedule.
There's a
Says
schedule.
Yes, yeah.
Monday, November 30th, chapter 7 on the Jasmine, the quadratic function.
It is December 12th. I mean, December 7th, rather. Yeah. December 7th is final exam part 2 from 11 a.m. to 1 p.m. Allegedly, 75 points. But I don't, I would say that you should plan to be at that meeting, all right? But I wouldn't expect that it necessarily is.
No, you found it online. Yeah. No teachers, every teacher that I've asked about the finals has just said, it's on the schedule on the UWA website.
Yeah,
I'm
they-
starting to think they don't even know when the test is.
I think they just like literally are going day by day and just like saying it. Because I literally have a final tomorrow that wasn't even supposed to be tomorrow. They just moved it. They gave me a study guide. He gave me a study guide with the answers and then said your final's tomorrow.
So what you're telling me is I need to be a lot more vague.
No,
No, this is good.
No, I would rather know when and what time everything is.
I need to tell you guys in advance so you'll remind me to do it. But no, like, so after Thanksgiving break, I have graphing quadratic functions. Have we talked about graphing quadratic functions already in here? I think we did. All right. Now, I can do more. What might even be better than a Zoom meeting necessarily, because Zoom is not good for doing math together. It's just not. Sorry, it's not. What we could do if, as you're working on your Chapter 7 homework, if there are particular problems in the homework which you find to be confusing, you can just send me an email, and what I'll do, I think this is what we should plan on, is, so like, probably I plan to, like, you can submit your questions about the video on the 30th of November, right? So you guys will be past Thanksgiving. You'll be working on homework again at that point. So once you have some questions about the homework from Chapter 7, just collect all your questions that you have, email them to me, and I'll try to make a video to address any questions that come in.
I was about to say, I would just make a video.
Yeah. So I'm.
A lot of my teachers are saying
Yeah, I don't think we're meeting anytime in that class.
I might feel different if we had material left to cover, but we've covered what we need to, so I think I can just address any questions that you guys have, you send them to me, I'll make a video. Now, if no one sends me any questions, I won't make a video.
All right,
So.
everybody start thinking of questions.
They have to be mathematical questions, like,
What is?
if you ask me about, like,
Test question.
if you ask me, like, what are the distinctions between, like, seasons 4 and 6 of Ninjago, I'm not going to answer.
What if I ask what are the test question answers? Will you give me the answer to
They're the ones that follow from correct mathematics.
You know what?
You guys are always like, how many, like, is there, I don't know if I've ever been to a test review where somebody didn't ask me how many questions are on the test. It's like, it doesn't mean anything.
Mixing a math test, that would be awful, but it would be cool at the same time.
You'd be the first teacher to ever do that.
Would you like to, I could give you true, possible, false.
True, possible, false?
Like multiple.
Yeah, true, false, possible.
What does possible
Let's just
mean?
keep it to the original, whatever you have.
That's what my brother does in his math classes. He gives the students true, false, possible. It's true if it's categorically true. It's false if you can find a counterexample.
What if it's
That's always true. It's possible if there's conditions which can be added under which it's true.
You know what? Let's not do that.
No, I don't think that would be wise. In fact, I think he stopped doing it after he still does it for like the upperclassmen, but not the too low-level ones.
You call us dumb.
No, I'm just saying it crushes the students.
Just ask him. Just ask him if he's calling us dumb.
I mean, I don't know who you voted for. Let's see here. Sorry. Test 2.
That's so hateful.
See, and you can interpret that joke either way you want.
So I can either get offended or I can laugh. Here, let's get in.
See, that joke works across the political spectrum because each side of the political spectrum thinks the other side is stupid.
Well, I think the other class are stupid.
You think the other section of 101 is stupid?
Yep.
I think that would be like a defensible position given you're in this section. And I mean, you don't want to call yourself stupid because then it calls into question, the validity of your argument. Like, who wants to listen to a person who's saying they're stupid say they're stupid? I mean,
Stupid.
I feel stupid listening to this conversation because I'm very confused right now.
Everybody's stupid. It's in the conversation.
I mean, you could bring,
Well, man, if I'm stupid, can I have the answers to the test?
you can derive the answers to the test during the test.
That's, you're using too many big words for me.
How about this?
Too
So-
syllable words.
Uh-huh.
You do it like a bank. You give us the answers now.
Like,
You back the answers to-
like a bank. I'm going to invest my answers in you, and then you're going to bring them back to me with interest.
With you, 'cause you
What kind of interest are you going to pay me on these answers?
How about this?
How much is on the line?
Let me negotiate. You give us all the answers to the test, but you get to give us 10 extra additional questions that we have to answer.
And if you miss one, you get them all.
No.
You still come out with at least a 90.
This sounds very confusing. I think I'm just going to give you a final. Let's see. So test 2, I'm going to remind you, we solved systems of equations, right? You might have forgot about that because we kind of did that and then we never did it again, right? So some of the things involving like isolating x or factoring inequalities, these things, number lines, interval notation, these things stuck with us past this point, right? But this was kind of an isolated event, but it's important to this course, 2 equations, 2 unknowns. Remember, I don't make you solve it by substitution. I don't make you solve it by elimination. I let you pick your path. So what I mean is you can add equations, you could subtract equations, you can isolate a variable. It's all up to you. You could use a graphical method if you're, very adventurous. Any questions about these? As I recall, the other thing that's important to remember is systems of equations don't have to have a solution. They can be inconsistent. The other thing that's possible that didn't happen on test 2 that could have and logically could happen on your final is the case of infinitely many solutions, right? It's possible to have infinitely many solutions if both of your equations are dependent, if they're really the same equation in disguise. Let's see here. So like this one, if I put a 6 instead of a 4 in the second equation, the answer would have turned out different, right? If I'd made this 4 a 6, then the solution would have been like any y such that, any x rather such that, excuse me, any y such that, I'll get it eventually. Basically, the solution set is all x and y that solve x plus 2y equal to 3. Anything on the line is a solution if it's the same line repeated. Now, in contrast, if the lines are skew, if they don't have the same slope, then there's one point and only one point of intersection, right? And so like this one, I gave you, I'm sorry. Hey guys, I owe you a blank test for studying for test 2 and 3. So
So you owe us at least half the answers for the final since we don't have anything to study with.
Yeah, because we haven't had enough
I'm-
time to study now. It's too late.
if only there was some way you could take the solution and cover up the answer which is provided.
If only there
To
was,
study.
but I have nubs for hands,
You have-
so I can't.
You have nubs for hands. That's very offensive to the nubby-handed people.
You're making fun of them right now. It's not my fault.
You started it. I'm not the monster. Let's see here. See, now we're getting close to the point where I'm going to need to edit this video. Thanks a lot. All right. Anyway, so this one, what I did was I found the slope of the lines to tell me what, this one has, it goes over 1 and up 2. The other one goes over 1 and down 2. So the one has slope 2, the other one has slope -2, looking at rise over run. And then I can look at the y-intercepts. Those are easy to see, 2 and 6, -6. So that gave me these two equations. Like just looking for slopes and y-intercepts is an easy way. And so there's my two equations and two unknowns. And as you can see, the point of intersection is -2, -2. And you can check that -2, -2 solves both of the equations for the lines in question. So that's a good check. I think almost everybody had something wrong with problem 4. Problem 5, evaluation. Order of operations is like super important. Notice that it is 3 times the quantity cubed, right? It's not 3 times the quantity, then cube all that, right? Like there's a very big difference between putting parentheses around 3 and x and then writing the 3 outside the parentheses versus what's given here. So that's pretty much all I can say about that. Any questions? All my word problems are fences. I had to come up with some new word problems. Sadly, I've already told you I would only give you the word problems I've already given you. Curses. I will have a bonus problem, which is words.
Do you know what's the answer to that's hard?
Same problem, just worded with like fence posts instead.
It's gonna be
It won't-
some, like trigonometry problem.
That's right. The fence won't be a rectangle. It's going to be a pentagon. I'm just kidding. I don't think we have the technology in here to do that just yet. It's the kind of fence you put around the pentagon. Naturally. I don't think there was a fence around the Pentagon.
My mom worked there during 9/11.
Oh my. Incidentally, people hitting the Twin Towers with a plane, that was, tragic, but not that impressive, really. Like, it's not hard for me to believe that somebody could get in a jet airliner and hit the two biggest things in New York City, right? But to hit the side of the Pentagon, Like, that is impressive. I mean, like, the kind of angle you have to come in to hit the side of the pentagon. I mean, that is a much, much harder thing. It's really unfortunate that they were able to.
Rather than hit the Pentagon, I meant the building that was the Pentagon. Because you have the Pentagon, you know, the actual obelisk, and then you have the building that's the
Ah.
Pentagon.
So it didn't actually hit. What did it hit?
They hit the building, they didn't actually hit the Pentagon. You're right, what you said is a true statement.
Oh.
If you would have hit the Pentagon, you're right, that would be impressive, but they hit the building that's, the Pentagon is the monument and the name of the building that's, is kind of, you're not actually gonna,
Ah, I see.
yeah.
I see.
Despite popular belief, the Pentagon, it might be held on. But I would find it hard to believe that that many people be working in that hollow space for that long.
Hmm.
I could be wrong.
I remember when it happened, we were expecting tens of thousands of dead in the World Trade Center. Like, it is a miracle that there was as few who died as there were. Because the number of people in those buildings at that time of day is a lot more.
And we have the stupidity to build that.
The what?
You know, then we have the stupidity to build that. Because, you know, World Trade Center that's supposed to be bigger than that. All I see is, I'm just hoping we don't piss anybody off here.
Hmm.
That one's weird.
Hmm.
And the only reason the first two collapsed was because they were poorly made. Because the way they had it structured was pretty much it was like a brick that had these metal poles that kept it in place. And when the planes hit it, superheated them. So the poles actually came apart at the seams. So the building actually ended up falling down.
Mm-hmm.
If it wasn't their fault. They couldn't. When you're an architect, you're never gonna account for, what happens if a plane hits my building? That's stupid. If you account for that, you expect something not to happen. You expect, for that variable to happen.
Right.
But it came down to the point where I don't even want to say if it was better made, because it was made just fine. But if it wasn't built like that, the Twin Towers wouldn't have collapsed the way it did, and you would have had more time to save all those people.
Right.
There's
Right.
still people who probably would have died from the initial impact, but there would have been more time to save the people who were still on.
Right. Well, nobody thought that those towers were going to fall.
And that's what I was saying. I was finding it interesting that it was like a small, tiny building mistake that caused the whole thing to collapse. And like I said, it isn't their fault. It's nobody's fault.
Mm-hmm.
It's nobody's fault because it's like, who plans that fault for that? You can't.
Right.
When the plane hits,
Yeah.
and it wasn't like, cause apparently there are like planes that have hit the Twin Towers before, but not,
Mm-hmm.
big.
Right. Right.
So, I always find that interesting, because it's one of those things where it's like, well, I guess this is why you always need to kind of have some sort of backup plan or whatever, take everything into account, but then again,
Hmm.
who takes it into account?
Yeah. Let's see here. So any questions about test 2 and the problems that remain? Everybody ready to complete the square?
So take half
Take half,
and then square it,
square it.
and then add the last number, and then just,
Yeah, don't forget to subtract the square of the number that you halved, right?
subtract the square, add the end number, and combine it to make it as simple as possible.
Right. And we can always double check our answer by just multiplying that out and making sure we get back to where we started. Just like every other factoring problem, right? If you're in doubt, multiply it out.
Don't come up with wrong.
That was an accident. Let's see here. Again, this is, I will post the blank copy of test 2, hopefully right after I'm done talking to you guys here. So you'll be able to use that. And, that this is a really important, like factoring, you can't look at my answer and study. Like, you need to work this without looking at these answers, right? So don't look at it. Put it out of your mind, but do try to do it yourself and then look at it and see if you got it right or not. Important strategies for factoring, if there's a common x in everything, pull it out, right? Factor x out if you can. Look for differences of squares. If you can find that, that's great. We talked about the slide and divide method for, if there's a coefficient of 2. If you like that, great. If you don't, try guess and check. Don't forget, we also have these handy-dandy special form trinomial formulas like a cubed minus b cubed and a cubed plus b cubed. Usually test on those in this course and then forget about them after this course. But I probably do owe you a question about the special form trinomial somewhere on the final. Like that's problem 9 part D on test 2, this sort of thing. If a student can do part E, it tells me a lot about them and their understanding. There's like a lot in this problem. First of all, like recognizing the squares, the square substitution, and then the fact that you can further separate x squared minus 4, whereas x squared plus 4 is irreducible, right? You can't do anything. Anyway, so factoring is important. Make sure you review. Test 3 should be a little bit fresher. For domain, we just need to make sure the formula makes sense, right? So for us, that means we need to avoid taking the square root of a negative number, and also we need to avoid division by 0. So that's all you need to know for problem 1, right? 2x plus 13 over x minus 6, when is that 0 in the denominator? Well, that's when x minus 6 is 0, which is to say x equals to 6 is a problem, right? So we want x not equal to 6. And so in interval notation, that looks like this: minus infinity to 6, union with 6 to infinity. So I think I just reviewed the solution to test 3, so I'm not going to do it all again here. Just, are there any questions you guys have about this? So.
That's what we went over Wednesday of last week.
Yeah. So I think that means we're done. That's all right with you guys. I'm going to go post those blank test solutions, so you'll have those. And
I'll be waiting for the test solution.
I'll probably end up sending another announcement out about like calculation of final grades because I'm still in the middle of that. I just corrected the 175 thing. I need to make an announcement about that. And I will probably grade these just as soon as everybody takes them.